Okay, next topic, the evolution of programming languages. So we'll see uh, the different programming language, how they got evolved, and the impact of that evolution, okay, over the compiler. Obvious, say the source program should be converted for the assembly level language. So who is responsible for that? Your compiler is responsible. We cannot restrict the user like you need to use the C itself, or you need to use the C++ or Java or .NET or C Sharp. Okay, such kind of programming languages only. Okay, he can like we have a flexibility. User should be having a flexibility like any programming language he is familiar with. Okay, that can be opted. Okay, so now what we need to do is these kind of evolution in the programming languages will obviously will be affecting the working of the compiler. So what we need to do, we need to improve our compilers also. We'll see the evolution of programming language, how it is going to impact over the evolution of the compiler also. See, here we are going to discuss the two aspects. The first one, move to high level language, and second one is impact on the compilers. Okay, so when it comes for move to the high level language, okay, so we are like there are many number of programming languages available over there. So we are going to classify these programming languages based on the generation and computation. Okay. So first we'll go through that generation to generation, how the programming languages got evolved, and second we'll see that based on the computation, how we can go for the classifying the programming languages over there. So here, the first generation to fifth generation, we got a different programming languages available over this. The first generation we call it as MC language, like machine code language. Okay, using a binary representation, we started the designing the programming over there. Okay, so that was not user friendly. So what we did, we come across with the assembly level language that we consider as a second level or second generation, we call it as. Okay, assembly level language means using the mnemonics. Okay, what we are writing for computer organization, MUPI and all. Okay, that we call it as assembly level language. Then later, the third generation, okay, we call it as a higher level language, like C, C++, Java, etc. What we are familiar. Okay, so that we consider as a third generation. And the fourth generation, using like application specific, we call it as. Okay, Nomad and SQL is the example we are using, like query based language. Okay, if anything is available or application specific programming is available, okay, then that we consider it as what, fourth generation it is. Then at last the fifth generation, okay, logic and constraint based languaging, like languages like Prolog and OOPS5. Okay, so these are the few examples like how generation to generation the programming languages got evolved and all. Okay, this is not much important, but for your knowledge sake. Then later, when it comes for classification based on the computation, imperative language we call it as, in which a program specify how computation should be done. Okay, like computer, what kind of computation should be done. Okay, how the logic should be. Okay, everything will be specified. Okay, we call it as imperative. Okay, so example for these imperative languages are like C, C++, and Java. Okay, so regular language, what user used to specify the logic and all, that we call it as. Then declarative language, second type of computation is what, declarative language. Okay, it specify what computation is to be done. Okay, it specify what computation is to be done. Okay, so the example for this will be Prolog. Okay, then later one more type of computation classification is von Neumann language we call. Okay, while discussing about the basic operational concepts of computer organization, we are using a structure called as a von Neumann architecture. Okay, so that is what, like how the system should interact. Okay, the communication between memory and the processor. Okay, so that we are considering it as what, von Neumann architecture, means the computer which all are following the von Neumann architecture for designing the system. Okay, so for them we'll be having a like von Neumann kind of language exactly. Okay, the computer organization programs, whatever we studied, okay, such kind of language. So that is also one of the type of a computation part. Then later, object oriented language, example C, C++ and all. Then script based language. Okay, so these are the few different computational part we got over here. Okay, script based at last means what, JavaScript. Okay, it may be a PHP. Okay, or else a Perl script. Okay, JavaScript, PHP and Perl all are used for the web application. Okay, it will be acting like a function. Okay, whenever we want we can call them. Okay, otherwise they'll be residing as usual. Okay, so these are the few computational classification we got and few generation based classification. Okay, so this is how the programming languages got evolved exactly. Okay, now we'll go through what exactly the impact of this evolution, okay, over the compiler design exactly. Okay, so obvious that if we have a advanced kind of programming language, then compiler also must be having a advanced kind of algorithms over there. Okay, so that it can be properly analyze the source program, properly divide them into a token, generate a parse tree over there. Okay, intermediate code generation, everything should be in a usual way, okay, or let's say proper way over there. So here when it comes for impact on the compiler, okay, so when we are using such a kind of higher level language, then obvious the new algorithm should be written for the compiler so that they can be handled, or a compiler can handle the different kind of programming languages over there. Okay, so the impact over compiler is what? The first thing is what? A new algorithm should be designed. Okay, then second thing will be adopt translation and support new language. Okay, obvious that the source program should be converted for the assembly level language. Okay, for this we need to adopt some translation procedure. Okay, because the syntax and the format of writing programming it differs from language to language. Okay, so it should adopt the translation procedure. Okay, and also support for the new languages over there. So this is what the second impact over the compiler. Okay, then at last the third one we consider it as should be suitable for hardware compatibility or capabilities. Okay, like we cannot, like it is also depending on example we studied like von Neumann language. Okay, the computer which are using a von Neumann architecture, right? Okay, so based on the hardware also we need to concentrate the evolution of the compiler. Okay, remember, so what kind of hardware we are using, what kind of communication we need to establish between the hardware and the software. Okay, regarding that also we need to have a concentration. Okay, so while evolving or while upgrading the compiler, we need to concentrate about three things. One is the new algorithm, adaptation of translation and support for the new language, and third one will be should be supportable for hardware capabilities over there. Then while doing this, we are have to face some challenges over here. Okay, your compiler should read millions of lines of code. Okay, maybe available. Okay, millions of lines of codes are available over there. Okay, so it should be read properly over there. Then later, next will be must translate correctly the infinite set of program. Okay, so it should translate the program properly so that the proper machine code can be generated. So these are the few challenges which your compiler is going to face, and the few evolution part, okay, which we have to discuss under evolution of programming language. So we'll move on to the next topic, the science of building a compiler. Okay, so under this we need to discuss two subtopics: modeling in compiler design and implementation, and second will be the science of code optimization. The name only indicates modeling in compiler design and implementation. Okay, this is nothing but what kind of algorithm we need to use, what kind of grammars we need to use for the designing of the compiler exactly. Okay, so we'll go through this. The study of compiler is a study of how we design the right mathematical models and choose right algorithm while balancing. Okay, obvious, like compiler will be working based on some mathematical model itself. Okay, like some predefined logic will be available. Okay, using which we need to convert the source program into the assembly level programs over there. So both should be balanced over there. Okay, so likewise, we got two different models mentioned over here. Okay, you can observe the finite state machine and regular expression. That is what the one famous and familiar model we can consider: finite state machine and regular expression. Okay, for lexical units, and context free grammar for syntactic units over there. Okay, so these are the few examples of a modeling. Okay, what we have, and implementation we got. Okay, then later when it comes for the science of code optimization, this is a bit important. Okay, so what kind of logic we are using for the compiler and all. Okay, it comes when we are trying to design a compiler itself, but while designing that, okay, we need to see to it that like whether we have a code optimization facility or what. Okay, if it is yes, okay, we need to see some objectives over there. Okay, design objective, optimization must meet the following design objectives. We will see that later. Okay, now what is the necessary of this optimization exactly? The word itself indicate, like we discussed already when it comes for like machine independent code optimization layer. Okay, so the intermediate representation of code, whatever we had, that should be converted, that should be minimized over there. 5 different lines we had, that was minimized it for only 2 lines. Okay, so for what purpose we are going to do this? Okay, to achieve the efficiency. Remember, okay, when we have a less number of line, okay, the time taken for the executing or time taken for the converting it for the assembly level language will be less. Okay, means we can achieve the efficiency over there. Okay, so that is what the main reason why we need to go for a code optimization over there. Then once we want to go for a code optimization, we need to meet these design objectives over there. We'll see that the first one, optimization must be correct. Okay, so obvious that we need to reduce the line. It is not like we are skipping some logic over there, so that because of this we may be facing some error, okay, logical error or syntax error sometimes. Okay, so that should not happen. Okay, so whichever is necessary, that should be available. Okay, which we feel unnecessary, that should be optimized over there. Then later, the second optimization rule is what? Optimization must improve the performance of many programs. Okay, obvious, when we have a less number of line, the performance will be boosted over there. Then later, compilation time must be reasonable. Okay, the time taken for the conversion should be less, and later engineering effort required must be manageable. Okay, for doing this optimization and all, okay, whatever the engineering effort we need to involve, okay, that should be manageable, we are calling it as. Okay, so that is about your the science of code optimization, modeling in compiler design and implementation. Okay, this is on the topic, the science of building a compiler.